Okay, we're going to continue with the component form of a vector. If we have a vector that has an initial point P and a terminal point Q, first I want to take a second and highlight some of the pieces, such as right here, that P1 is our horizontal component going left and right. And if we are trying to find out a component form, which is just a kind of an ordered pair form of a vector that tells you how far left and right, how far up and down, that we are going to be taking those two, the horizontal components that we have here, and we're going to be subtracting them. It's like subtracting your x values. And then for the other part of it, to know the vertical component, we will look at what kind of looks like the y values of our initial and terminal points, and we'll be finding the difference between those two, and that gives us our official component form of our vector. So there's the official component form of our vector. It has that initial point, it has the terminal point, and basically this one tells exactly how far and what direction it goes. That's a vector. Magnitude, we started talking about that in the first video. This is just the distance formula, and its sister formula is Pythagorean theorem, and you can see exactly where this Pythagorean idea is in here, taking the square root and taking each component from the vector and squaring them, then adding them together, and then taking the square root. And this all makes sense when we do an actual example of it. A little note here about a unit vector, and you've heard the word unit before. When we described a unit circle, it meant that the circle had a radius of 1. Well, if we're talking about a unit vector, it means it has a magnitude or a length of 1. Another thing is that if you have a vector whose magnitude is 0, that means that that vector is what we call the zero vector. There's not much to it, it's just a point. All right, let's actually use this idea now. It's not as complicated as it looks. All right, find the component form and the magnitude of the vector v that has the initial point -4, -1, and terminal point 3, -1. Well, let's see. I'm just going to sketch myself out a little grid here. So this is my x, this is my y, and I have it's starting at -4, 1, 2, 3, 4, -1, and it's going out to +3 and -1, so it goes to -4, -1, so it starts there and it ends at 3, -1. Oh, that has, it's completely horizontal, it has no vertical. Notice that. So find the component form and the magnitude of the vector. So if we're going to do the component form, sometimes we call this process head to tail, where this right here, the initial point is the tail, and the terminal point is the head. So we're going to take the head minus the tail. All right, so our vector, let's call this v, is going to be the vector. Now we're going to take and find the difference between the head and the tail. So we're going to take 3 from here, and we're going to subtract the tail's horizontal component, which is -4. I'm subtracting -4. And then the next piece, do the same thing, same order. Do -1 from here, subtracting -1 from here. Well, we can just clean that up a little bit. So this is the vector 7, 0. And that makes great sense. Its horizontal component is 7. There's 7 units there, and its vertical component is 0. It does not rise at all. So the component form is 7 comma 0, and the magnitude is going to be pretty simple. In fact, we already have it sitting in front of us. It's 7. But if we start to look at the formulas and things that we've been looking at the last one, we would say that the magnitude of V is the square root of 7 squared plus 0 squared. And again, I got those numbers from the component form, from the 7 and the 0. So that's where those come from. And of course, we'll square those and add that together. So that's square root of 49, which is simply 7. So there is the component form and the magnitude of a vector.